Please take it over.
Thank you, Ted. First of all, thanks for the opportunity to showcase really two projects we worked last year, both in the state of Iowa. And while they're totally different approaches, we usually just do transportation projects, corridors and whatnot. These are two different projects that while they're different, we share the same approach. A little overview of what we're going to be discussing here is we're going to give you a quick company overview. Then we're going to jump into the city of Perry, Iowa. And then we're going to talk about artificial intelligence landing done in Cedar Rapids, Iowa. We're going to wrap it up a little bit, and then we'll open for questions.
A little bit of a company overview with us. We work with Foth Engineering. We're based out of Green Bay, and John and I, we work with our infrastructure solutions team. Kind of our bread and butter are DOTs, municipalities, and airports. We do a lot of work in all of those fields. Another aspect of our business, we have the environmental group, which they focus on a lot of mines, landfills, and coastal mitigation. And our production solution folks, they do factories, a lot of breweries, a lot of food processing. So if you can imagine, an animal goes on one side and hot dogs come out the other, kind of thing. So, and we've had the pleasure to work with all three of our divisions and do a lot of work with them. So I'll push us back to John, and we're gonna go through some data collection and what we call the two ends of the stick. And originally we had the smart end and the other end, but HR made us say the two ends of the stick. So I'll let John take it over here.
Yeah, what we're seeing here, this picture represents actually a beautiful era. This picture of a crew back in the 60s and going in early stages of a highway construction project. But at the same time, it also represents a concept that we still use today and applies to what we do with laser scanning operations. There's always two ends of the operation. In this case, the rod man and the instrument man. But nowadays, we use it as field collection as one end, and then the office part of it, which is the quantification, qualification, and the processing of that data collected. And we know that laser scanning have been here for a while, since the 60s. And we have been using it for decades in civil infrastructure. And we always been delivering CAD formats. We just get the data in line work format. The project gets built, then the data goes back into a closet and stays there forever. And what took so long to get some software that really embraced the longevity of the project? We need to first think about the ability to process the data, and in a matter of minutes instead of days, using platforms like TopoShare to put that data in for our clients, to the shareholders, give that data to the people that really makes decisions. And that, for us, is the other end of the stick. I'm going to pass it to Dio and talk about City of Perry.
All right, so moving on. So I'm going to start with a little quote here, and it's a lot of times people don't know what they want until you show it to them. And that was by the legendary Steve Jobs. So a little bit about the city of Perry. My home office is in Des Moines, which is the capital of Iowa, and Perry is just to the northwest, about an hour. It's a town of about 8,000 people, and they've got a real rich history. It's interesting because they were a railroad town through and through, and since then railroads have become more obsolete, and a lot of the trails in Iowa, they've had a Rails to Trails program. They've converted all those over into bike trails. So bicycling is a big thing in central Iowa, and that's something that they're very proud of. So We did a full city scan of Perry. It consisted of about 120 lane miles of roadway and 10 miles of alleyways. And how we originally approached this is, I actually had a relationship with the city administrator from a previous employer that I had, so I just kind of kept that alive. And as I was talking to him, and this is over the course of a couple years, I'd sit there and say, hey, we've got this mobile LiDAR scanner, it's really cool, and he'd be like, you're a dork. Like, that has no application to what we're gonna do. And I kept talking to him, and hey, we've been doing a bunch of ADA ramps. Wait a second, we could do that. Can you help us with the transition plan? Absolutely. So that's where it started. And as it progressed and it morphed into many more things, as you can see, the public engagement was huge. We had the newspaper calling us. How can we use this? How can we incorporate this into our capital improvement plan? The parks were really interested from the trail aspect, from how many benches do we have out there? Instead of having somebody go out and manually collect them, what does it look like? How does it feel? That kind of thing. And that was all information that we were able to collect. Another thing that came up was the historical preservation of their downtown area and their main street. They've got a lot of really cool features and artwork. And unfortunately, in the Midwest, we've got tornadoes, and we had, this is in 2020, a derecho, which is basically straight line winds over 100 miles an hour, and it just topped all the trees. We lost a ton of tree coverage, but the historical preservation was a big thing. Less than an hour away, there was a town that their entire downtown got obliterated, unfortunately. And looking at from a historical preservation approach, how do you rebuild that? Another thing that was really important to the city is we gave them 360 videos of every street in town. And, we can just use Google Maps, right? Well, in small cities like this, they don't get updated like a Chicago or a big city every 6 months or every year. I mean, we use 3 or 4 year old data for a lot of these smaller communities that we have. Here's another example of, as we were scanning the city, this came up. So you can see in the right side of the screen here, there's a little jog. 2 site developers came in and basically they shifted the road, and that's supposed to be a straight road. And one of the thought processes with this, had this have been scanned, the entire city, we would have had data that would have said, hey, this is all, something's going on here. So it was definitely avoidable. And it's just something that, it's in the toolbox and the city can hopefully use in the future. So by the numbers, we had over 3,000 tiles, and part of our deliverables were to upload this into TopoShare. A lot of the city staff, they're not technical people, so being able to access this information and see it is very important to them without having to pay another subscription for a CAD software or program or whichever. So we were able to upload it all into TopoShare, and they've been able to use it, and it's been really, really handy. For the raw data, we had over 4 terabytes worth of information. And, towards the end of it, our final product was around 500 gigabytes. So here's some examples of some of the information that we collected. So if you look into the top right of the screen, we actually extracted a chunk of Main Street so we can show the city what we had done. So we extracted everything, did some asset management tools for them. As you can see, the stoplights, the signs, all that was put into an inventory system so they can catalog it and see it. And again, this is just for a chunk of it. Towards the left, that's a picture of the downtown with the point clouds and the intensity values. You can see towards the left of that picture, there's a globe looking thing. Those are globe lights that the city has throughout the Main Street and downtown area. And they're really proud of all that stuff, and they want to make sure they have the right placement. You can't really see it, but there's a tree through in there, and then they have a bunch of really neat artwork and different things as attraction values. So, as I had mentioned with the derecho, one of the things that, again, as we were going through this process, the city administrator had mentioned to us that, if FEMA comes in, they need to have northing eastings on all the trees that they want funding or help with repairing. Boom, we've got it. So when the derecho came through, there were cities that lost over 65% of their tree canopy. And, that's a big number. And, millions, we had several projects that we were mobilized to Cedar Rapids and Des Moines for, just to go out, do drone data, just to see what the damage was. And with this, effectively, we had all the trees within the city right away. So that was a really important thing for the city. And it's one of those things that we didn't think of. From engineers and a surveying perspective, we're thinking of the roads, we're thinking of the ADA ramps, all the assets that we can collect. But there were things, historical preservation, that wasn't on the top of our mind, but it was on the cities, and we're happy to add that in there. Here we got some more photos or screenshots and captures of, the area. Again, all the red is what we scanned. So it took nearly 3 days to use our mobile mapping system to go and collect all this information. It took almost 2 weeks just to catalog all the 360 videos. And again, this is like an 8,000 person city. Not huge by any means, but definitely not small. We also were able to provide a Pci data analysis of this. That's the top right picture. And we were able to go up ASTM standards and basically do it and compare it to the DOT information that they had on record. And then this would be Mr. Peterson. He is the city administrator. And, it's a nice little quote from him. And it goes back to things from an engineering and surveying perspective that we don't think of. But one of the things that he had thought of was autonomous vehicles. He's like, we have the whole city scan. Let's call Ford up and see if they want to do a test program. So it was kind of neat to see different things as we work through the process with them. And go back. As we work through the process with them, future projects, and we'd actually brought up, potentially doing this with new construction projects, or every 5 years do another scan, see if there's new trees they planted, how big those are, so they can keep their inventories going, new streets, that kind of thing. So overall, it was a really fun project to be a part of. We learned a lot. This is the first one that we did, and there's a lot of good benefit and a lot of good value that came out of it. The client was happy, we were happy, and we hope to do many more in the future. So with that, I'll hand it back to John, and he will talk about some AI aircraft landing that we were part of.
Thank you, Dio. I'd like to start with a little quote here by Henry Ford. It just says that if I had asked people what they wanted, they would have said faster horses. Little background on this project. In 2020, as you all know, there was a pandemic year, and that was very challenging for the aviation sector. There was reports of $371 billion loss globally, and passenger numbers went down 2.7 billion due to the fear of getting COVID and business being closed. There are projection models that forecast, even then, this happened in 2020, that there will be a 2 to 3% growth in passengers increase by year 2039. So that basically launched the R&D effort towards the US mission goals, which basically is having the safest, most efficient aerospace in the world, and has sustainable growth in the global civil aviation, and continue the development of airfield autonomy. And what is this? What this all entails? It entails airfield operations, improved safety and security, and all these to mitigate that revenue losses. Adding to the problem is that there's a shortage of pilots. There's a shortage of people to work in the airports. Like we all know in the industry, it's hard to get people to, qualify people to work. So the airline industry or the aviation industry is actively investigating multiple airside advanced solutions for common operation, just like snow removal, mowing, FOD detection, which is foreign object detection, baggage handling cards, the tugs, the cards that push the aircraft, jet bridge movement, and perimeter security monitoring, which all translate to good, the need of precision airfield asset mapping. And that's where we jumped in. The interesting part about this project, this is in Cedar Rapids, Iowa, is that we have a joint effort with this defense contractor. Basically, they approached us and said, hey, we need you to locate all the lights on the roadway and taxiways and get us a measure down to the ground, because we need this piloting system to track that very precisely. So we said, yeah, we can do that. We can go out and take a shot, measure down, write it down, catalog it. But that's where the MLS came into the matrix. It's like, yeah, we can do that, or we can scan the whole airport, give you everything that you will need today and potentially tomorrow. The solution provided by to the defense contractor, originally, again, like I said, they wanted just these GPS shots, and we provided them the TopoDOT feature extraction on a CAD platform. We put everything in TopoShare for full cloud immersion for stakeholder collaboration. We provided the full color imagery so they can see additional features if they need to. The additional value that we added to the airfield in general, because now we are using that data on the airfield itself, we did a runway profiling, taxiway Pci analysis, and extraction support for paint markings and other advanced vehicle mapping needs. On their side, their solution is basically the precision landing mode. They want to locate those lights, and while they're approaching, usually what the system works right now is at 300 feet, the pilot takes charge and land. With this proposed system, basically, the airplane will take down or land, and just 10 feet above ground, there's a little input from the pilot. So from 300 feet to 10 feet. So basically 18 seconds of that landing operation is what the pilot needs to do. So how they do that? They use GPS, they do avionics systems, they do navigation aids to help approach that setup. So the final adjustments are done rapidly and quickly, and the minimal intervention of a human being. This is the medium intensity approach light system. Basically, those lights extend the runway so the pilot can make adjustments. Now, in this case, the airplane will do the adjustment itself. This is how it will look for that airplane. Another look at that detail on that lighting system. So we're going to talk about the value added. Like I said before, we collected a lot of data. Now that data is in a platform that any stakeholder can play with, get information as needed, and obviously can communicate with us if there's any need. We get them the CAD file, and we identify all the lights that they really needed in a matter of days instead of weeks. So, a picture of the lights extracted. To summarize the project, basically there's a need, shortage of aviation staff. The technology development helps improve the aviation safety, experience, and efficiency. They're developing a lot of unmanned usage of bridge movement, the snow removal, the baggage handling, all the gate movement will be in the future automated. There will be little to no human beings down there, unfortunately for them. And the utilization of MLS really was paramount to be able to give them the accurate data in a short period of time and have them really push the project forward real quickly. I'm gonna wrap it up and then soon I'm gonna leave it for questions if you guys have any. What I wanna convey here is that no matter the technology that you deploy in certain specific project, never ever assume that the client knows what you're an expert on. It is our duty to give them options, to educate our clients so they can have more information than what they need. Make sure that we evaluate all the alternatives and propose the best approach possible to our clients. And this way, hopefully, will be the winning formula to close the cycle of the two ends of the stick. Thank you.
Any questions? Oh, can you hear me? Okay. Any questions? No? Okay. Oh, there's one. Okay.
For the citywide scan that you guys did of Perry, how long did that take from go to completion of the process data?
That is a very complex question, but I will try to answer the best way I can. So collection took about 3 days. That is setting control, going there, going every road, every alleyway, every trail in that particular town. Then went to the office, spent about a week and a half of putting everything together, making sure that everything is aligned. And then we spent 2 weeks cataloging the videos. They wanted 360 videos of all their system, their transportation system, basically. Then we did some extraction. I think it was about a mile of the main street that we provided line work. We provided PCI analysis. We provided ADA ramps reports, and the surface, obviously, what they needed. So that took about another 3 weeks. So in total, in about, we'll say, month and a half, we went from 0 to end. Now, you have to account for, too, that we did some extra training. So this is part of, kind of my message here is TopoShare is a very great, powerful tool. We need to educate our clients on how to use it. It looks simple, but when you're talking to rather an engineer or a guy that just is the truck service person, you need to make sure that you digest that properly, right? So you give them, I think we give them like 2-hour training, and it's continuously evolving. So every time they call us, hey, can you help this guy? And we just provide that feedback. So it's an ongoing project. I think we built a very good relationship with the city, and I'm sure this data will be very useful for them.
Yeah, on that TopoShare note, one of the feedbacks that I had gotten was, TopoShare in our head is pretty user-friendly. Like, it's easy to get into. And when we gave the spiel of like, hey, here's how you do this, we tried to slow it down as much as we could. But again, these are non-technical people. And the feedback I got was, you guys need to come back. You went way too fast. So just getting them up to speed has been its own challenge, but it's been good. because getting them to understand what it is and what questions to ask has been very beneficial for us and for them. So, but it's been a trip, that's for sure. So.
But David, on that topic, are they having trouble with like visualizing? I got a top view, and these vectors are the camera view, and that's what I'm looking at. Is that do they have trouble putting that all together?
A little bit, but it's not even that complicated. Because I look at TopoShare like it's like Google Earth complexity, and their first question is, "What's Google Earth?"
Oh,
That's the problem, right?
Okay.
You need to know your audience, but there's people that have high technical knowledge, and there's people that barely touch a computer to complete their timesheets, right? Actually, they probably do it on paper. Yeah. So it's that type of deal that is kind of a barrier that we need to start breaking by budgeting these things. We need to educate, and these communications leave budget for that because you will need it.
yeah. I think one of the fascinating things I got from that was like how the applications grew, though. I mean, you had the city administrator going, first it was we just need a little bit, and then all of a sudden oh wow, we can do this, we can do ADA ramps, we can do our planning, we can do volumes, we can look for change, we can do, and which says a lot as to what we can do with our technology, and that's a little a relatively medium-sized town in Iowa. There's so many opportunities out there.
And we didn't mention this, but so we are from Iowa, and it's actually warmer there now than it is here, which is kind of wild. But we've had multiple projects where, oh no, we don't need to scan it; it'll be fine. And then we'll do this in August, September, when it's nice and great and sunny. And then come January, the client will change their mind, and be like, hey, can we just add another 500 feet? And we have to go out and chip ice and snow off curb and gutter to make sure we can get a good elevation on these shots. It's like, oh man, we should have scanned this. It's a lot easier to extract, joint lines and points and whatnot, than go through and go out and chip ice. So.
Question. There it is. That's what they've got.
You say you catalog videos in addition to the photos. You take video while you're driving it.
So usually we do both, but for this particular video, we use the 360, the ladybug imagery and convert that to a video. So a full 360 video, so they can do like you do Google Earth Street View kind of deal. But it came on from the same system. We didn't have to do anything extra.
Yeah, we'd have to drive it twice. It was all part of the package, I guess.
After that project, we decided to use a little Garmin Verb or something to also capture that because the user interface is a little bit more user-friendly.
Yeah, appreciate the questions.
Yeah, another one out there, I think.
Hello. When you guys scanned that city, did you submit a registered point cloud? And if so, how many targets did it take for you to?
I don't know the number out of the top of my head, but we did a lot of physical ties and then check shots throughout the town. It took, after the scanning was done, we sent crews out to get photo identifiable targets and then shoot them. How many? I don't have the number in the top of my head, but I'll get back to you on that one for sure.
Okay.
Well, interesting. You say photo identifiable targets. You just pick things you can see in a photo, things you can see in the point cloud, and say these are.
Right. Go ahead and shoot.
So you didn't put cooperative stripe, box targets or anything.
No.
Yeah. That's interesting. There's I'm having deep thoughts about some of that stuff too. Is like because you're starting to do. I mean, there's a big demand for looking at volumes of pavement volumes, like before and after, and you can't put control on this road, right? So you have to find things, and they'd like to just drive it once and drive it again, but you have to line them up really well. So we're kind of looking at that. And in TopoDOT, you guys know you can move things around. You can actually we don't like to register data, but you can. We just don't want to be responsible for it, But we can take 4 or 5 points, do a least squares fit. So if you find the same 5 points, it'll do a least squares fit and move it linearly, not in small areas. So that's kind of or you can go back to your original software and do it the whole trajectory if it's a longer
Right.
place.
And
you know,
then
which is
take it to TopoDOT.
probably
do
the proper way to
the
do it,
trajectory.
really. But we can find those targets in TopoDOT, you know, it's finding the common points you can find in TopoDOT, and that's kind of where we would fit in and actually feed back to the trajectories and stuff and do it the correct way there. That's something where, you know, it's being asked for. I'm just waiting for it to get a little momentum, but I think it's, yeah, big application also. Any other questions? Okay. Well, thank you very much. That was really interesting, guys. Really appreciate it.